All right, so number one, just so you know, I'm not going to go over all of the restrictions. I'm just going to go ahead and solve these problems quickly, and then you can think about the restrictions. Usually it means that you can't have any negatives inside the square root, so it has to be greater than or equal to 0, and then you just can't have denominators that are equal to 0. All right, so what are we trying to isolate here? Let's underline that. So we are trying to isolate for G, right? So we're trying to find out what G is. So let's underline that there. So I would say we should undo the multiplication here first so that we get that part in the bracket on its own. So let's divide everything by H. Okay. And that will undo the multiplication. So then we have GK plus J equals M over H. All right, and logically we're going to subtract J now. So let's subtract J from both sides. All right, so that's gone, and we have GK is equal to M over H minus J. And so it's pretty simple. We've got to divide by K. But let's look at it this way because we've got some fractions over here. That's like multiplying by 1 over k, which is the same thing. So I'm going to show it that way. Show it, well, here I can say it's dividing by k, but that's really multiplying by 1 over k. Same thing. And then multiply by 1 over k. And then so we end up isolating g now, which is what we wanted. And we have m over hk minus j over k. And there are other variations of that as well. Okay, so number 2, we are trying to isolate h. And it's inside of the square root, which is like a bracket. So what we need to do is undo this multiplication outside of that special bracket. So I'm going to divide everything by g. So we're going to have the square root of j plus hk is equal to m over g. All right, we know what to do here. We want to undo the square root. So the inverse of square rooting is to square. And we know that just will give us whatever's inside the square root. So let's go ahead and do that. So I'm just going to square. I have to square the whole side. So if I have a binomial on this side, I have to square it, the whole thing, not just square each piece separately. We need to square the whole side, whatever's there. Okay. So I'm going to square this. I'm also going to square this. So we end up with just j plus hk, right, is equal to m squared over g squared. And what were we isolating again? We are isolating j, right? Sorry, h. So we're isolating h, so logically I'm going to subtract j, okay? So I will subtract j from this side and also this side. Okay, so let's rewrite that now. We have hk is equal to m squared over g squared minus j. Okay, and then pretty simple, we just got to divide everything by k. So when we do that, it's the same as multiplying by 1 over k. Let's with red, okay. So I'm going to show it that way, actually. Let's times this by 1 over k. We're going to do that to each part here. So times it by 1 over k, times it by 1 over k. Okay, so this becomes h is equal to m squared over g squared k minus j over k. All right, so this time we're isolating t here, and you can see we have it twice. Well, let's see. I mean, a lot of people are saying, okay, if I multiply everything by nt, maybe that will work things out because I won't have any fractions. We're going to undo that multiplication. So multiply by nt, and let's do the same thing over here. Multiply by nt. So yeah, that cancels that fraction. So we have t minus m, but then we still have p and t over here. Okay. So how are we going to do that? Well, we know that if we're factoring, we could use t as a common factor. So first, what we need to do is get all of those parts together. So what I can do is I could go ahead and there's a few ways I could do it, but if I add m here, yeah, I've isolated t. Now I say that t is equal to p and t plus m. But I have two t's. I haven't isolated them completely. So let's subtract p and t from both sides. So I'm going to subtract p and t. And when I do that, then I have the two t's together. So I'll have t minus p and t. I'm not sure if that was a capital or a small p, anyway, is equal to m. And now I can see there's a common factor there, right? So the common factor is t, which is going to be quite nice. So I'm going to factor out t. So it's just going to be 1 minus pn is equal to m. And now I just need to undo that multiplication. So I'm going to divide everything by, let's see, 1 minus pn. Okay, and do the same thing over here, 1 minus pn. Okay, so that will cancel there. Let's move up a little bit. And we have t is equal to m over 1 minus pn. That's it.